Okay, this is video number 5. Now we're going to talk about what you've colored your video, what you've colored on your periodic table in this video. There we go. So the first one is Hund's rule. When we talk about Hund's rule, we're basically putting one arrow representing an electron into each orbit in the up direction, because positive I get my own seat and the red would represent negative I have to share. It's sort of like the empty bus seat rule. You know, everybody wants their own seat until there's no more seats to go around, then somebody has to pair up. So this is not correct because that would leave an empty seat. So everybody gets their own seat and then we go back and pair it with the red going down. That's known as Hund's rule. Then we get the Pauli exclusion rule. So the Pauli exclusion rule basically says in one room, if I have a bunk bed, basically one has to be up and one has to be down. They both can't sleep on the down or the up. So that's basically what Pauli's exclusion rule means. Every orbital has to have 2 electrons in, but they have to be opposite spin. Then we get to Aufbau. Aufbau says basically you've got to fill the lowest energy levels first and then move up to the higher ones. Going forward to this one. As we look at these on the periodic table, I've sort of circled them over here so you can find them. We're going to do orbital notation. So on oxygen. Okay, so oxygen. Let's try that again. It's going backwards. Okay, so oxygen is right here. We always start at 1. So we're always going to start at level 1 because that's where we begin every time. And when we start at level 1 right here, okay, we're in the 1, we're in the S block. The S block has 1 room. We're going to put 1 in for hydrogen, so I'm following through. And now I keep going on that row. I'm going to get to helium. I'll put 1 down. Then I'm down through helium. Now I go to the next row, row 2. And it's the S block. It has 1 room. And I'm going to put 1 in for lithium. Up. 1 in for beryllium. Down. Going across. I'm going to hit boron. And now it's in the 2p. 2p has 3 rooms. So in the 2p, I'm going to hit boron. And I'm going to go 1 up for boron. Then I'm going to hit carbon. 1 up from carbon. Then I'm going to hit nitrogen. 1 up for nitrogen. Notice I put them all in their own individual rooms. But now when I get to oxygen, I've got to go back and pair. And that's the one I wanted, was oxygen. So it's going to have 1 down. And I use half arrows. You can use full arrows, whatever you would like to do there, as long as they're arrows up and down. Now I'm going to erase this. We're going to go on the next one. Chlorine. Again, I start at the top one, and I'm going to this one right here. So chlorine, I'm still going to start at the 1s. I'm still going to go through hydrogen and helium. So I'm going to have an arrow up and an arrow down. Then I'm going to get to the 2s. I'm going to have an arrow up and an arrow down because I'm going to go lithium to beryllium. Then I get to the 2p. Remember, p has 3 rooms, or 3 orbits. And I'm going to go all the way through that because I'm not going to get to chlorine before I get through it. So if I go all the way through, I'm going to have 1 up, 1 up, 1 up, 1 down, 1 down, 1 down. I'm going to fill that orbit. Then I get to the 3, and I hit the S again, and it has only 1 room, so I put 3s, and I go up and down because I'm still not to chlorine. And I go all the way across, and I hit 3p. And 3p has 3 rooms. And I'm going almost to the end of it. So I'm going to have, let's count, 1, 2, 3, 4, 5 arrows to get to chlorine. So 1, 2, 3, 4, 5. And that would be the orbital notation for chlorine. Okay, let's do it for copper. I'm trying to change colors so you can sort of keep track of where everything is. So copper is right here. And I'm going to start again at the very beginning, up at the top with 1. So 1s, arrow up and down because I'm going all the way through and coming down to this one. And by the way, when I get done, I should have the number of arrows that the atomic number is. So I'm now at 2s, and I'm going to go through lithium and beryllium again and get over to boron. 1, 2, 3, because we hit the 2p. And we're going to go all the way through to neon, and that's going to fill those orbits. So up, 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 down, down, down. Then I get to the 3s, and I'm going to go through it. 1 up, 1 down. Get to the 3p. It has 3 rooms. The p does. And these are where these things are coming into play. Okay, so I go 1, 2, 3, 4, 5, 6, because I'm going all the way through that row. Now I'm at the 4s, so s has 1. And I go up and down because I'm going to make it all the way through. Now at this point I hit the 3d. And the 3d has 5 rooms. So I'm going to 1, 2, 3, 4, 5. This is my 3d. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 to get to copper. So 1, 2, 3, 4, 5, 6, 7, 8, 9 to get to copper. Okay, so I want you to try, well, let's do carbon together because it's a harder one. And then we'll go from there. So carbon, it looks like it's going to be, let's see, erase this. Okay, carbon we start up here and it is right here. So carbon we're going to go 1s, arrow up and down. I follow with my finger, don't cross out your periodic table. 2s, up and down. And 2p, it looks like we just have 2. Now carbon's a special column. It does things its own way. It says, hey, on the second level, I have an empty room. And this poor guy has to share in 2s. So let's just take him and put him up here and let him have his own room. So he's no longer in the 2s, and everybody on the second floor or second level has their own room. And that makes carbon more stable. Okay? So this is what it's called. Just went out of my head. I'm sorry. When I think of it, I'll tell you. It's, I'll have to come back to it. I lost it. Okay, so let's go on to zirconium. I want you to try and do zirconium on your own. I'm not going to talk you through it. I will put an answer up here in just a minute. Zirconium is right down there and it's circled in white. So again, try and do it on your own. Okay, how did you do? Did you go okay? Awesome. Let's go ahead and go on to the next page. We'll do one more page and I'll stop this video. Maybe. Just thinking about it. Okay, so that gets awful long. So I'm going to put these back up because for some reason I've got them. Okay, so we use what's known as electron configuration because those arrows get really old, but you've got to know how to do the arrows because you've got to be able to do the orbital notation. So instead of doing arrows, when we do electron configuration, we just tell where we're going. We're going to start the same way as before. We always start at the first one. And this one we're going to nitrogen, which is right here. So we would start, we're starting in the 1, in the S, there's 2. Then I'm going down to the 2, in the S, and there's 2. Then I'm hit the 2p, and how many in the 2p am I? 1, 2, 3. Done. Okay? So I want you to take a second, go ahead and do it, pause the video, and then come back when you're done and check and see how you did. Remember carbon's group, carbon's column about halfway down, they'll steal from the S and put it up in the P, so everybody has one in their outer, one in their orbit. Okay, coming back really quickly, let's see how we do. 1s2, 2s2, 2p3, 3s2, 3p6, 4s2, 3d2. For selenium, 1s2, 2s2, 2p3, 3s2, 3p6, 4s2, 3d10, 4p4. For carbon, 1s2, 2s2, 2p2, but, I remember the word now, hybridize. It hybridizes and becomes 1s2, 2s1, and yes, we do write the ones, 2p3. And then rubidium, 1s2, 2s2, 2p3, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1. All right, so hopefully you got that right. If you need to stop it and try and figure out what exactly I did, go back through it like I did here and just follow with your finger until you get it. Or come get some help. All right, I'm going to stop there for today. Go ahead and do what you need to get done.